In this video, I'm going to take you through Gaussian elimination with partial pivoting. Gaussian elimination with partial pivoting is an upgrade of naive Gaussian elimination. This upgrade is to correct round-off errors. Also, this upgrade is to correct division by zero. So because of these two limitations of naive Gaussian elimination, that is why we use Gaussian elimination with partial pivoting to solve problems in order to cater for the limitations for naive Gaussian elimination. I have a problem here. Let's go into this problem for you to understand Gaussian elimination with partial pivoting and why we use this. Now, in this problem, the condition is we should use 5 significant figures with chopping. I'll let you understand the meaning of chopping. So, 5 significant figures with chopping. So, first of all, when we see the chopping, assuming you have 5.8425, you are to leave this with, let's say, 3 significant figures, or let me say 4 significant figures. So you have 1, 2, 3, 4. You realize that to stop at the 2, you need to round it so that you get 5.843. But when you are finding significant figures with chopping, you only take the 5 out and it becomes 5.842. We don't round it, we just chop everything away. So once you reach your 5th significant figure, you chop the rest away. That is the meaning for significant figures with chopping. Now let's go into our problem. Whenever they give you a problem, a system of equations to solve, the first step is to write your augmented matrix. So let's see. Now I'm going to have my augmented matrix to be the coefficient of what I have. So I'll have 10, negative 7. I don't have x3, so to be 0, then 7. So 10, negative 7, 0, then your solution, so that is the b part, will be you draw a line, then you bring your 7 just here. So that is for the first part. For the second part, I have negative 3, 2.099, then 6. Negative 3, 2.099, then 6. Then I have 3.901. 3.901. Then the next thing is 5, negative 1, 5. So I have 5, negative 1, 5. Then I have 6 here, right? So I write my 6 like this. This thing I've written here is also the same as writing 10, negative 7, 0, negative 3, 2.099, 6, 5, negative 1, 5. Your x1, x2, x3 is equal to your b, which is 7, 3.9016. Now let's see. Let's concentrate on what we have here. At this point, we are going to use Gaussian elimination, alright, but we introduce a pivoting. To begin with this, we need to eliminate this term, this term, this term, so that we get an upper triangular matrix. Then we can use our back substitution to get the values for x1, x2, and x3. So to start with everything, our first elimination we do with row 1 and row 2. At this point, we can divide this by this, so there's no need for any pivoting. So the first step is you have negative 3 over 10. So you divide negative 3 by 10. Let me clean this. So negative 3 over 10. Then you multiply this factor by row 1, everything in row 1. So negative 3 over 10, when you multiply it by 10, you are going to get what? Negative 3, right? When you multiply negative 3 over 10 by negative 7, what are you getting? So negative 7 times negative 0.3, and that is giving me 2.1. So I get 2.1. Then if I multiply it, I will get 0. Now, once you get this, you come and subtract this from our equation, our second row. So you redraw and you get what? 10, negative 7, 0. Then you subtract this from here. Negative 3 minus this is 0. Right? And that is what? The elimination here. Now 2.099 minus what? 2.1. And that is giving us negative 0.001. Finally, 6 minus 0, that will give us 6, right? So I'll close it, my x1, x2, x3. Don't forget, the multiplication, you add the multiplication to the b. So you need to multiply the negative 0.3, that is negative 2 over 10 by 7. And that will give us negative 2.1 here. Then you subtract 6 from what? Here, because we subtracted it row 1 from row 2. So we are going to have 3.901 minus what? Negative 2.1. So it's going to be plus. So plus 2.1. And we are going to get 6.001. So let's see. I'll have 7. So this will be equal to 7 here. Now this becomes 6.001, right? Then I'll have here to be 6, then here to be 5, negative 1, then 5. Once I get this, the next thing I'm going to do is to eliminate my third row. My elimination, I will just divide 5 by 10. So 5 over 10, that is row 3 over row 1. Then I'll multiply it by all the factors in row 1, all the members. So this by the 10 will give me what? 5. This by 7. So 0.5 times negative 7. That will give me negative 3.5. 0.5 times 0 will give me 0. Then I will subtract this from my what? Third row. C. I'll subtract this from my third row. So I'm going to get 5 minus 5. That will be what? 0. So let me draw my third. So my 10, negative 7, 0. 0, negative 0.0016, right? Then my third row, 5 minus 5 will be what? 0. At this point, I'm going to subtract negative 1 here. See, you subtract what you have here from this place. So I had here, I multiply 0.5 by what? Negative 7, right? So by negative 7, I had negative 3.5. So negative 1 minus this, because I'm subtracting this from my third row. So I'm going to have negative 1 minus 3.5. Negative 1 plus 3.5. And that will give me 2.5. So I'll be getting 2.5 here. Then finally I have 0. So 5 minus 0 is what? 5, right? Then I'll have my x1, x2, x3. At this point, I'll apply my 5 over 10 by what? This, right? Sorry. So 5 over 10 will multiply my first row as I'm doing. So 0.5 by what? 7. And that will be giving me 3.5. Then I'll subtract this from what? My third row, because I'm dealing with the third row. So 6 minus 3.5. 6 minus 3.5. And that will be giving me 2.5. So I'll get my 7, 6.001, then 2.5. Then move on. So right now you can see I've eliminated my first row here. The next elimination is to remove this. But see, if I divide 2.5 over negative 0.001, it will be a huge number and it will affect my solution. This is where the pivoting comes in. Now, what the pivoting is saying is that we have to switch rows when if when when you are adding or dividing and you get 0, or when there is an invalid arithmetic, you are supposed to what, switch rows to compromise. So the pivoting here, what you are going to do is you are going to have 10, negative 7, 0, right? Then this will go up. So my last row will move to the middle row. So now I get 2.5 here, then what? 5. Then my middle row, that is the row 2, will come to what? Row 3. So it's like row 2 switching to what? Row 3. That is my pivoting. So now I get negative 0.001, then 6. My x1, my x2, x3. But when I come here, I will interchange as well. 2.5, 6.001, 96. At this point, I move to my third elimination. For my third elimination, I'm going to divide this negative 0.001 over 2.5. Then I'll multiply this factor by my second row. When I multiply this by my 2.5, it will be equal to what? Negative 0.01. Then when I multiply this factor by my 5, what am I getting? So if you have negative 0.001 over 2.5 times 5, and that will be what? 0. Negative 0.002. Now the next thing to do is to subtract this from what? Our last row, because we use the factor to multiply by row 2, then we subtract it from what? Row 3. So drawing back our matrix, I'll have 10, negative 7, 0, 0, 2.5, 5, then 0 here. Now negative 0.001 minus 0.001 will be 0, right? Then here 6 minus this is going to give me 6.002. Then at this point, I'm done with my elimination. Multiplying x1, x2, x3. Is that not it? So this will be equal to, when I come to this side, I multiply this expression by my second row and subtracted it from my third. So it will also affect it. So 7 will come here, 2.5 will come here. But I'm going to have negative 0.001 over 2.5 multiplying what? My 2.5 here. And I'm getting 0.001. Then I'll subtract the 0.001 from my last row, and that is going to give me 6 nicely. So once I have this, you can see that I'll have 6 multiplying what? Okay, sorry. Now we are going to what we call the back substitution. Back substitution. When we say back substitution, we are going to multiply this to get the values for x1, x2, and x3. So 6.002 x3 is equal to 6. Hence my x3 equals what? 6 over 6.002. And this is going to give me, so 6 over 6.002. And this is going to give me 0.9997. So if I'm to use my chopping, So let me write in 4. I'll have 0.99966 as what the value for x3. Now, from the second back substitution, I'll have 2.5x2 plus 5x3. 2.5x2 plus 5x3, right? At this point, 2.5x2 plus 5x3 is equal to 2.5. I know the value for x3, so 2.5x2 plus 5 multiplying 0.99966 is equal to 2.5. So I'm going to get 2.5x2 to be equal to, when I multiply this, when you have 5 times 0.99966, I'll be getting 2.5 minus what? 4.9983. So I'll get 2.5x2 is equal to, so 2.5 minus 4.9983, and that is giving me negative 2.4983. So my h2 is simply equal to negative 2.4983 over 2.5. So negative 2.4983 over 2.5. And the answer is going to be h2 is simply negative 0.99932, right? Then finally my x1, I have 10x1 minus 7x2. So let's see, 10x1 minus 7x2, and here is 0, so 0x3, so to go is equal to 7, so it's equal to 7. Now 10x1 will be x1, our x2 is what? Negative 0.99932 equals 7. Let me do this multiplication. So negative 7 times negative 0.99932, and I'm getting 10x1 plus 6.99524 equals 7. So 10x1 is equal to 7 minus 6.99524. So 7 minus 6.99524. So I'm getting 10x1 is equal to 0.00476. So over 10 over 10. Then finally, I'm going to have my x1 to be equal to 0.0004, so it should be 76, and that is x1. So my x1, x2, x3 is simply equal to what I have here, 0.0000476. My h2 was negative 0.99922. Then my x3 is 0.99966. x3 is 0.99963. And this brings me to the end of this class. Thank you for being with me and watching this video. Kindly subscribe, like and share.